Hello grade 12s and welcome to some more trig equations. We are nearly at the end of this section and it's pretty much downhill from here. This little concept does not require a calculator because if you receive a question where you have the same trig ratio but different angles, you can jump straight to your formula without having to press shift on your calculator. How do we do that? We just link whatever we are given to the correct formula that you have practiced and practiced and practiced by now, and then you link up the one angle as your theta in your formula, and then the other angle can represent your reference angle in the formula. So for example, if you are given sine A is equal to sine B, so sine of something is equal to sine of another thing, you can link up the angle on the left hand side of the equal sign to represent theta in your general formula, and then instead of whipping out your calculator and pressing arc sine, you can just link up the angle given on the right hand side of the equation to the reference angle in the formula. You can do the exact same for cos, and you can do the exact same for tan. But what if you are given a negative in the equation? What if you have a sine of a specific angle is equal to the negative sine of another angle? Then, not to worry, all you need to do is apply one of the following three formulae. Now I know what you're thinking. Oh no, I thought we'd done memorizing new formulae. I don't want to have to now deal with a whole new concept, but it's really not tricky. If you look at these formulae very carefully, you would see that because we are dealing with negative trig ratios, we are merely working in the quadrants in which these trig ratios are negative. So again, I'd like to emphasize how important your cast diagram is. If you have a look at the first sine A equals negative sine B, you can see that yes, we can sneakily drop our signs. If sine A equals negative sine B, then A must be B, but in the negative sign quadrant. So A is actually 180 plus B. Why? Because if you look at the 180 plus quadrant, you'll see that's quadrant number 3, and that is where sine is negative. Likewise, for A would be equal to 360 minus B. Why? Because that is quadrant 4, and in quadrant 4, sine is negative. So the same applies for the negative cosine quads as well as the negative tangent quads. Basically, we are just adapting our formula that we've used thus far to become the formula in the correct negative quadrants because we are given a negative trig ratio. So let's jump straight into an example. I've tried to choose a tricky one so that you can see how difficult this could get. It really isn't that complicated. And here we are required to determine the general solution of cos A equals cos B. Why am I saying A and B? Because those angles given in brackets are not identical to each other. So remember our regular formula that we use for general solution for cos. I am now, instead of theta and reference angle, which can be a little bit confusing, especially because I'm repeating myself with the symbol theta over there, let's rather replace our theta and our reference angle with the letters A and B. And then let's call the degree, well, the angle on the left-hand side of the equation A, and the angle on the right-hand side of the equation we can call B. And what do you know? We just plug it into the formula. So A is equal to B plus K360. And instead of A, I've written 2 theta plus 45 degrees equals, instead of B, I've written 20 degrees minus theta. Now let's kick our 1 theta over to the other side of the equation, take our 45 over, simplify to get 3 theta equals negative 25 degrees, and last but not least, divide everything, even the 360, by 3 in order to get theta all by itself. And we end up with -8,33 degrees. Are we forgetting something? Yes, we are. Don't forget to say k is an element of an integer, What about the OR option? Now we need to show, right, there are two quadrants in which cos is positive, so A could also equal the negative version of B plus K360. Instead of A, I've written 2 theta plus 45, and instead of B, I've written 20 minus theta. We distribute the negative, we take our thetas to one side, we simplify, and we get theta is equal to -65 plus K360. It's as easy as that. The second example applies one little extra step, but nothing that you can't handle. The problem here is that we are dealing with a sine and a cos. We don't have a sine and a sine, or a cos and a cos, so we can't jump into one of these formulae that we've learned today. First things first, we're going to have to change things up. And when you see a sine and a cos, never fear, we can use that co-co rule, the co-function formula. Why don't we change this cos on the right hand side to be a sine? How do you do that? You just do it. If you see a cos 2 theta and you want to change it into a sine, go for it. Write sine, but don't forget to pop a 90 minus into the bracket. Okay, so now we have a sine equals a sine. So we're not dividing, but you can imagine dropping those signs in your mind and then remembering, because of the negative in front of the sign on the right hand side of this equation, we are going to have to work in the negative sign quadrants. So that is quadrant 3, the 180 plus quadrant, and quadrant 4, the 360 minus quadrant. I'm going to link up my A and B's. A is going to be theta minus 60, B is going to be 90 degrees minus 2 theta, and pop it into the formula. So A is equal to 180 plus B. Make your substitutions and get all your thetas to one side of the equation, all your degrees to the other side, and simplify. Divide everything by 3 and we get theta is equal to 110 plus K120, and K is an element of the set of all the integers. Right, don't forget the OR side of the equation. A is equal to 360 minus B. Instead of A, we've written theta minus 60 degrees. Instead of B, we've written 90 minus 2 theta. We distribute the negative. We take our thetas all to one side, our degrees all to the other side, and we divide by that negative theta. We'll -1 to get theta is equal to -330. If you also divided the plus K360 and you made it negative K360, that's perfectly fine. Because K is an integer, that sign in front of the K will always depend on whatever integer you substitute in the place of K. So whether you write plus K360 or minus K360, it really doesn't matter, because K could be any integer. And that's that. I'd like to remind you to please go over example 16 on page 158 before you tackle the rest of exercise 4.9. Off you go. Enjoy.